Sorry, I think I just... Yes, I'm back. So can you guys see my screen? Share now?
Yes, and your sound is perfectly fine.
Oh, nice. So I hope I will not lose you this time. Today I'll talk to you about giving a presentation in mathematics. Actually, there are lots of resources on how to give an effective presentation. So today I will mainly focus on what happens in academia and what happens when you are presenting a mathematical subject. Like that's what I know best. And I want to start with a disclaimer. So I'm more used to giving mathematical talks, but this is a more opinion-based talk. So what I'm going to be telling you is going to be based on my personal experience and thoughts and the opinions I've formed throughout the years when I was giving presentations and when I was listening to presentations. And you guys might have different experiences, different ideas.
So now I can just pick your pattern movement first.
I did not catch that.
I think it was unintentional, Hocam. You can continue.
All right. And we can maybe discuss what your experiences and opinions are at some point, and you can always ask questions. But I guess this is not a mathematical level of correctness. So with that, we can start planning your presentation. And this, I think, is one of the biggest mistakes that happen when a younger person is presenting. In general, undergraduate presentations tend to be too hard and too complicated, and it is generally very hard for the audience to follow because they are too high level. And as people become graduate students and professors, the talks tend to become simpler and easier to follow, and it is actually very natural because as a student, you are just learning something new and you're excited and you tend to want to prove yourself to the audience. It might be your instructors in the audience or your peers, and you want to show them like how much you have learned and how you understand and can talk about complex mathematics. But when you're, that means that you tend to base what your talk is on your own needs, right? It should be based on what your audience needs. So it's not about how much you know and how much you can tell. It is about how much your audience can follow. So a talk should almost never be about showing off how much you know about the subject. It should be about people listening to the talk and their experience. And there are small exceptions. For example, if you are doing a job talk and it's in front of a hostile audience and you need to use big words that they do not understand, otherwise they don't take you seriously, like that could happen. Hopefully not, but wait, there are always exceptions, but mostly a talk should be about the audience. So questions you can consider, like what's the aim of the presentation and what is the target audience and what you can assume they know. If your audience is undergrads, as it will be for the CRP presentations, then you can assume that they know some basic calculus and like if the standard courses you take in the first 2 years. But you cannot really assume that they are very advanced. And if you start with, okay, I know we are all familiar with the classification of groups and then continue, nobody is going to be able to follow your talk. So you should be making logical assumptions on what your audience knows. And what would be the main idea or ideas that you want people to take away? Because even if you do a great talk, it is unlikely that a lot of people will be able to follow your whole talk. So what are the important points, and like what are the ideas that you think your audience can take away from that? That's something to focus on. And keep in mind, the first is, after you study the subject, it feels easy to you. But it might not be easy for the audience to follow the same thing. For example, you give a simple definition, and you think that any mathematician seeing this definition can play with it and get this result, and that is correct. But in the talk, they do not really have time to think about and play with the definition. So it might not sink in, and even if it feels simple to you, it might be complicated to the people listening to you. And this also applies to like researchers or professors in the audience. Like they might be very good at mathematics, but you probably know the specific subject matter better. So like they might not be able to easily follow everything you are putting out there as well. So how do we approach this? Like giving lots of examples and adding some visuals is a good idea, especially when you are defining something central. You should add an example while the definition is also like on the whiteboard or on the slide, so they can sit side by side and at least understand the main definitions a little bit. And giving proofs is generally a bad idea. So you can talk about maybe the idea behind the proof, like you can say, like you play with the equations and the one side follows, the other side is a bit technical, use a little bit linear algebra. Like you can talk in general terms, or you could give a sketch of proof, or you could just talk about the results, and that would also be okay. Just putting a technical proof out there and adding like this, well, oh, this is what happens when m is equal to n plus 1. This is the n case. And like when you add stuff like that, people would generally not benefit from that and not be able to follow. And one more thing, this is actually a comic from one of my favorite webcomic series, XKCD. And this is about a person talking to grad students and pretending to be an expert in their area and how long it takes for the grad students to tell. And in engineering, it's very fast, and he goes to literary criticism where it takes like a long time. And the reason I was mentioning that, it is in mathematics, it is really fast for people to understand you do not know what you're talking about. So never ever talk about something that you do not really understand, because people can tell. People can easily tell that you have no idea what you're saying, and it's like people would not be happy about it. And I have been to talks like this when somebody was just saying very weird stuff, and it was really hard to be an audience member there, because like you feel the need to interrupt and correct stuff, and then that's very hard for the presenter to be corrected, and especially if it's a younger person, like it becomes messy. But even if you are very good at the subject, it is possible that, and like there often is one or two people in the audience that are really experts on some part of the subject, and they know that better than you. So in mathematics, you cannot really wing it and just use a lot of words, and like people would be able to tell. And one other thing, be nice to the audience, because like academical audiences, mostly they are friendly audiences. So people are polite to each other, they ask nice questions, they do not really want to offend anyone, especially if you are a younger student or a researcher, they're especially polite. They do not want to discourage you from continuing. They know it's hard to give talks, it's hard to learn about these things. So like you could do lots of mistakes, and people would really overlook them and support you and give you some tips and ideas. unless you openly antagonize them. So, like, if you are mean to any audience members and like, if you are very rude, then that will just kill that goodwill. So that's something you do not want to do. So in short, you do not have to include everything you know in your slides and in your talk, and never ever include stuff that you do not know. So then it's time to prepare your presentation and what program to use. The most common answer is LaTeX, especially, specifically Beamer. This is a very common tool to use in many presentations in academia, and I think BRP is going to have a template for you to use if you want to. And like it is easy because it looks professional. It's like it is easy to use, and if you have other notes in LaTeX, you can copy paste the code and it still works. So most people in conferences or in talks use LaTeX if they are going to use slides. But I've started seeing more and more people using handwritten notes on tablets as well. So they basically write their presentation and on the tablet and then scroll down or change slides, and like that works too. They can generally include more detailed pictures that way. And like if you are uncomfortable with any of these programs, then you can always do a classical talk. So no slides, you take the chalk or marker, you go to the board and you talk. Because this is like the old school way of doing mathematics. It's always okay, and you can always, like, even with a very, very big audience, you can see an old professor giving a chalk and blackboard talk. So that's never an issue. If you have trouble with the slides, you can go that route. And using PowerPoint or like Google Slides as I'm doing today, that is more common if you are doing a popular talk with lots of pictures, or if you are teaching, like if words and pictures are the big part of the talk and not equations, then people use PowerPoint or Google Slides or other slide programs. You could use it in the academic setting. It would be a bit unusual, but not a big issue. So what I would advise you to not do is to open a Word document and show people your notes, or to directly open your paper and try to do your conference with that, or even worse, directly open somebody else's paper or book and then talk on that, because that shows that you did not bother to prepare something for the presentation, and you are just basically the audience tends to feel that you do not value their time enough to actually prepare, and that can come across as rude. And the one time I walked out of a talk was when a student was giving a talk in a Turkish conference, and the talk was in Turkish, but she was using her notes on Word that were written in English, and the concept was very simple as well, and it was quite annoying. Like, not fully the students' fault, the advisor should have told them and taught them how to do, but like in a professional setting, it was very off-putting. And then the second important subject, like the first to me, is to making sure that your talk's appropriate for the audience. Second is how to design your slides if you are doing a slide talk. And the idea is your slides should accompany your talk, so they should not exactly match your talk. And you might think that in this particular talk I'm making right now, my slides are nearly exactly matching what I'm saying. And that is on purpose, because I thought that it is possible that some of the audience will not be as comfortable with English as the others, and I am not a native speaker. So I thought it might be easier if there was the visuals of the text as well. If anybody is having trouble with understanding what I'm saying, then they can read the slides and get mostly the same points. But this is not something I tend to do when I'm giving mathematical talks or I do not have similar worries. So internal slides tend to go more formal. You put definitions, theorems, results, and details on that, and they use more correct mathematical notation, and the details are on there. And when you are actually explaining what's happening, you do it in a less formal way. So you do not actually read out every little detail. You do not really focus on the notation. You just talk about the idea, what's happening there, what's the deal, what that theorem means. You sometimes draw pictures, so you also give connections to other parts of the subject. So as an example, so this was from one of my last talks, and I was giving a definition, and I like to give the definitions with examples. So it might be an example following a definition or going before a definition. And the colors can be really helpful with that. So I gave the definition like this, we discussed it, and then we were looking at more examples, like which ones are bottom interlacing, which ones are top interlacing. And I tend to talk a little bit about this, and then I point out that, okay, the top ones are all bottom interlacing, the bottom ones, it depends on which side is larger, the leftmost point or rightmost point, and talk a little bit on that. And then I gave the conjecture we were working on at that point. And this conjecture, when you look at it, it does look confusing, and I never read the conjecture. The slide doesn't stay open for very long. I just say, okay, the things we were discussing, the conjecture here says exactly that, and then I move on. So this is a tool of giving the actual formal definition, but I explain what the conjecture says step by step before that in this example. So like that, you can use your slide set, definitions, notations, results, theorems. Like you can put the mathematically correct stuff there. You can add helpful examples, visuals, you can add calculations. Or like the example, you can have longer versions of stuff that you are briefly mentioning. For example, if you are referring to a part of a poem, you can put the whole poem on your slide, and people can see that while you are actually talking about the specific part. You can add references, and references could be both references you use in the talk or you don't, but like if somebody is interested in that subject, this is a reference you would like to recommend. Like that's also a type of reference that's good to add. You can also talk about the motivation or the big picture in the talks, or you can try to emphasize things you want to emphasize. But the rule of thumb is, like, if something would be hard to follow without seeing it written down, it should go on your slides. So the slides should really help the audience follow your talk. And some more examples. So like this, for example, is a slide on the motivations, and these actually appear one by one, and I say, okay, there's a paper like this is on that. Like I do explain it in slightly more detail in the talk, but people can see in a compact way, okay, these are some motivations. And this is from another talk where I wanted to show people how the new stuff I'm talking about connects to stuff they already know. So type A is the more well studied, and the audience was mostly familiar with what happens there. And I put it side by side with type B and C, which I was working on at that point. And I also included some examples, and like actually throughout this talk, I used the orange color for everything type A and the purple color for everything type B and C, which I think helps, at least it helps me just to follow the talk more easily. So it's an extra visual clue. And this is another example, and this I added to show like you do not really have to fill every slide to the same level. You can also use your slides for pacing. So one slide, it's just mostly empty. There is only a small bit of information. So that's sort of a point I wanted to pause and like start simple. And then in the next slide, that piece actually moves up, then more details are added, and then more details. So he's sort of playing with like less material, more material, like slower, faster. These are things that can help people stay awake during the talk. I also wanted to add a slide on what to expect during a presentation. And I think many of you might not need this, but let's just have a thought directly. Like if you have not been to a mathematical presentation and you do not know how it goes and you are nervous, this is how it goes. And like they generally do follow the same pattern, whether you are talking online, whether it's a big conference or a department seminar. There is somebody, a moderator, an organizer, or session chair, and they introduce you and your talk. So I think today I was introduced by Kürşat, and then you thank the organizers for inviting you, organizing the event. I hope I did. And then it's time for your talk. And questions during the talk may or may not be allowed. It's generally session chair might give an idea on that. I think Salia said like if you have questions, you can write them in the chat, or like you can. I can also say like you can interrupt and ask me questions. But for that, you can generally either follow the session chair's lead, or if they do not say anything and you have a personal opinion, you can also express that. And then after your talk, you end your talk by thanking the audience for listening. Clap, clap, clap. And then the session chair thanks you, asks the audience if anyone has questions, and like if there's usually one or two questions, and if there's not, then the chair would ask you a question, not to be rude, because it is considered rude when nobody asks any questions. It gives the feeling that nobody was listening. So like some brave soul would ask a question, just not to be rude to the speaker. And then the chair thanks you again, and they move on to the next event. And like if you have slides or something technological that you are not sure gonna work, you can talk to the organizers beforehand, either earlier that day or maybe email them, or even 5 minutes before your talk, like let's check the computer and make sure it works. And you can, if you have feelings about questions, you can say like, feel free to interrupt me, or please hold questions till the end. And the timing of the talks tends to be important. Med talks generally do not, like if you have 15 minutes, then it will be nice if you finish in 15 minutes. So the academic talks not go for 30 minutes when they are scheduled for 15 minutes. The schedules tend to be semi-tightly packed, so it can be like a few minutes over, but the session chair would stop you if you go on, or they would tell you, oh, you have 2 minutes left, or you can say, can you wrap it up? We need to move on. So that might happen if you keep talking, and I would not advise you to keep talking after that. Like that would be really, really rude. And what can you do to make it fun for the audience? Something you can do is like you can be enthusiastic about the subject, and generally, like if you find it interesting, that translates really well. But you should not be trying to teach people. So do not place yourself as an instructor, like at a higher level than the audience, like unless like you are like 80 years old, you're an emeritus, and people are like, if you are it's a very special talk and you are sort of more experienced than everyone else, maybe, but in general, think of yourself as an equal of all the people you are talking to. Like, you have something interesting you want to say, they share the same interest, they might like it, you are all enjoying it. So you're not their teacher, you are a friend, you are a colleague. And asking questions to the audience is a good way to engage them, but be careful. Like, you shouldn't be asking trick questions, or you shouldn't be asking questions that you plan for them to be wrong, so you can say the right thing. Like, do not embarrass people with your questions, and do not ask questions and then wait for a long while so people get really stressed about it. Like, be nice in your questions, because people are in front of their colleagues and they do not want to get embarrassed. And like, anybody can give a wrong answer to a med question when put on the spot, and they will be embarrassed if like their friends and professors are around. So don't do that. Just when you're asking questions, like, keep them light, easy, and like you can use some jokes, like, or you can tell a funny story or two. So these tend to go around, but do not do too much of it, because the point should be the mathematical content. So like, you shouldn't be the focus, the subject should be the focus. So do not put too much personality in, just some is one. And the same thing goes for visual effects. Like, academic audiences, when it comes to talks and how the talks go, they tend to run conservative. So you can watch a lot of Beamer talks and they might go pretty much alike. And like, creativity and thinking outside the box would not really be a plus in that setting. So be cautious to not do too much. And like, if everybody's doing a Beamer talk and then you have theatrical costumes, they would think you are overcompensating for like not actually knowing the mathematics of your talk. So be nice, but one thing the audience are generally not conservative about is how you dress. Like, they generally don't care, t-shirts and jeans, okay. Or like, if you wanna wear something fancier, that would also be okay. It is like many departments also tend to very relaxed dress code, and also med conference. So like, people would not expect you to dress up and would not really judge you for your clothes, like, at least in my experience. Audience questions. So an audience member might ask you a question during your talk or at the end. And like, if you think there's a chance that everybody heard the question or understood, like, it's a good idea to start by rephrasing the question and repeating it. Something like, also, you are asking how we come by this limit. And that also gives the audience member a chance to say, oh no, I'm not asking that, I'm actually asking something else, if you are the one misunderstanding. And remember that it can be scary to ask a question, whatever level you are, because like, you put yourself out there, and generally the subject is slightly new for you, so you might have misunderstood something and you think, oh, am I saying something really stupid, or am I actually have the correct things? So sometimes people's questions will be trivial, sometimes they misunderstand stuff, and be nice to them. It's a hard position to be in. Like, do not make them feel like, oh no, this is really straightforward and you are just missing it. Say that, well, that's a nice question, and that's like, people misunderstand that sometimes. And the type of question that you often get is people are generally interested more in their own work, and they will ask you like, if your work has possible connections to their work, so they'll ask you like, oh, do these pet algebras have any representation theoretic connections, or like whatever their area of interest is? And like it's okay to say, I haven't considered that. I'm not very knowledgeable on that. Do not try to guess the answer. Do not try to say more than you know. Like it is okay to not know the answer to the questions. And it really happens like sometimes an audience member like really keeps asking back and forth questions or it's talking too much, and you can politely say, okay, let's continue afterwards, continue in the break, or you can say, oh, I really need to go on with my presentation. But generally the session chair might interrupt as well in a situation like that. And like things you can say, like when somebody asks a question, you can say like, excellent question, oh, what a great question. Or you can say, this is a very natural question to ask. Like, and if they are saying something that's wrong, you can say, oh, that's an easy mistake to make. Most people think that, or like you can say, oh, I know, like it feels like that should be true, but it's not actually in this case. It was surprising to me as well. Or you can say, if they're asking something hard, you can say, oh, that's actually very tricky. Let's talk more on the break. I can email you, or you can say, oh, that's surprising. I haven't considered it, but it's very interesting. Let's talk more later. And that's like if you want to probably continue the conversation and maybe some research project with that question, that person might be in the cards in the future. Like so you can show that you're interested in that, or you can say, oh, that's good, and you can say, oh, I know a good reference and I can share that with you if you want. So there are also ways to answer the questions. The key point is be nice, and if you do not have something that's meaningful to say, you can just redirect it to the break or to emailing later, and then you can draft a clever response in the meantime. And other details consider, like one is choosing good references, and this should not be a big problem for your DRP tool because you already all chose your references, I think, but like be careful on it. So academic books, peer-reviewed papers, they are generally good references. But like if you are referencing a personal website, blog, popular article, then like you should know like who is actually writing it. Like, does this person actually know like Galo groups and write about it, or do they just have a small, very general idea and they're just writing some true and some false stuff? So anybody can start a website or a blog, so you should try to be reasonably sure that they know what they're talking about, or you can also compare with other sources. And if you are looking at Wikipedia or similar sources where like they are not actually people writing what they know, but they are compilations of information that they find in different places on the web, and then they have their references. So if you find an interesting piece of information in Wikipedia, there would be a source for that because Wikipedia is compiling information. So if it's a good article, then one of the references should be mentioning the information you found. So what you should be doing is actually looking at that reference, finding the information there, maybe finding more information there, and citing the reference instead of the Wikipedia page. And one more detail that's really important to me personally. I'm trying to both do better myself and set a better example, because I think this is something that we do not discuss enough in Turkey, like copyrights. So you cannot just go online and Google and just take an image and copy and paste it to your presentation. Like you could do that technically and nobody would prosecute you for it, but it would be both illegal and unethical, and we should not be doing that like in academia. And you can ask, what if I mention what website I took it from? it's still not okay. They might not want to share it, even if you mention their name. So what you can do instead is, like, if you are looking at Google, there are some copyright filters. You can say, okay, I want to look at images with Creative Commons license only. So that means that you can actually use those images if you are citing them properly. So you can search especially for that. And like Wikipedia often has Creative Commons images, or you can also look at other image sources where a lot of images are free to use. You can draw your own images or use AI generators, which is okay at the moment, but like the laws on that might change because the AI generators study other images that might have copyright. So like the judges still out on that. And you can also, like, if you like some image, you want to use them, you can just email and ask, like, I found this image on your website or on your paper. I'm giving a talk. Is it okay if I use it? Because these are actually people that you can talk to each other. And I want to finish with some final tips and maybe disclaimers. So this is the general sense I have of how academic presentations go, from like the international events I went to, and I've been in Turkey and then the US and then in Sweden for a while and in France. But like your particular, the place you're in, like country, city, department, workplace, they might have different norms, like especially, for example, if you're in a small university and they do not get many visitors from outside, they might have formed their own culture. So I say that dressing casually is okay, but you might be in a department where like the department head will be offended if you're not wearing a suit. So like always try to watch presentations and see what the norms are, and as colleagues maybe if you have some doubt. So like it might not be universal. So you might end up in a place where rules are different. And watching other presentations is generally a good idea. Like that's what I based my ideas on. So you watch others, you try different techniques, you try to understand what people are doing well, how they can improve, and how you would be able to improve. And you can look at the reactions of the audience. You can ask them, like, did you like that talk? What did you like about that talk? Like maybe not many questions unless they're your advisor, but some questions are fine. And lastly, like I discussed many things to do and not to do, but like do not stress it out too much, because mathematicians do not tend to be very good speakers, because like mathematics is not something like public relations where you interact with people all the time. Like people might minimally interact with others and be sort of awkward and not the best speaker, and that's generally okay, that's expected. And if you know the subject you are talking about, if you made an effort to prepare an actual talk, and if you are nice to the audience, you'll be fine. And yes, thank you for listening. And they are not there at the moment, but I will also upload these slides to my website, so you can also find them there. And yeah, this is it.